Alright, so in this video we go over section 5.6, factoring special products, in which we are going to factor perfect square trinomials, factor differences of squares, and factor sums and differences of cubes. So let's start with the first topic, factor perfect square trinomials. Well, so in this case, these are the forms for perfect square trinomials. In fact, earlier this week, we learned how to FOIL this guy and turn it into that. Now in this section we go over how to factor these guys and turn it into the expressions as in the right hand side of this formula as well. One pattern to recognize is that the first and the third terms are perfect squares. That is, a and b are perfect squared. And the second piece of information that you might want to recognize in the pattern is that, well, we need to take the square roots of those two quantities, all right, and those are going to correspond to the middle terms of these guys. When we multiply the square roots of those numbers by 2, we have to obtain the same thing. Okay, so let's look at a couple of examples to illustrate how this goes. Well, so the first thing we do is let's identify a. So what quantity squared equals x squared? Well, in this case, x. And b, what quantity squared equals to 25? Well, that's a 5. Now we need to multiply 2ab. So 2 times the quantity A times the quantity B. Alright, so let me actually use different colors here so you can see what's going on. Highlight this with pink, I'm going to highlight this with green, and I'm going to multiply the quantity A, which is x, times the quantity B, which is 5. Well, so let's highlight with the corresponding colors just so you can see what's going on in here. So we need to multiply this 2 times x times 5. That's going to give us 10x. And if you think of this, well, this actually matches very, very well. This 10x right here is exactly this 10x here in the middle. And all we have to do is we identified a and b, simply a and b squared. However, well, in this case, a, which is x, and 5, which is b, quantity squared, but with the sign of the middle term in the middle of these two. And we are done. All right. Okay, so let's see if the second, if example B is a perfect square trinomial. Well, so the quantity A is which quantity squared equals x squared? Well, that's x. Quantity B, which quantity squared equals 36? Well, that's 6. Now we need to multiply 2a and b. That is 2 times a, 2 times b, which is x and 6. Let me highlight this again. And all right. So when we multiply 2 times 6, that's 12. 12x. Right now we need to verify. Does that one match that guy? Well, in this case, it's not a match. Here, these don't match. So in this case, we say that not a perfect square trinomial. Not a perfect square trinomial. Let's call it PST for short. Alright, well, in this case, we need to find out another way to factor this one. Well, factors of 36 that add up to 21, I don't think there's any. But, well, that's not the point of this section. So, the point of this section is to identify perfect square trinomials, and if they are, then factor them that way. Let's look at another example. Well, now the leading coefficients have a number different than 1 as opposed to examples A and B. So we need to find the quantity A, which is the quantity whose squared is 4x squared. In this case is 2x, because 2 squared, that's 4, and x squared, that's x squared. On the other hand, well, 25, that's B. the number whose square is 25 is 5. Now we need to multiply these two numbers, 2ab, or these two quantities rather. So 2 times the quantity a, 2 times the quantity b. 5 and 2x. Okay, let's again highlight them where they correspond, just so you can see what am I doing here. Alright, we need to multiply 2 times 2, which is 4. 4 times 5 equals to 20 times x. Don't forget the x. Now, is that 20x matching this 20x? You may ignore the negative sign for a minute. And yes, in this case, it's the same. It doesn't matter if you don't have the negative. This negative is going to be used soon. So in this case, well, this is a perfect square trinomial, right? This is 1. So open parentheses, quantity squared, the quantity a, which is 2x, the quantity b, which is 5, and then in the middle we are going to put this negative sign, the same sign as in the middle term. Now let's go back to verify that. Well, so in this case, see this plus sign here is the same as that plus sign here. See this negative sign in here is the same as that negative sign in here. Alright? Let's do one more. Quantity A, which is the quantity whose square is 36, that's a 6x. 36x squared, so 6x. And B, the quantity whose squared is 81, that's 9. So 2ab, that's 2 times a times b, so 6x and 9. So let's highlight so you can see all this. And highlight. So 2 times 6, which is 12. And then 12 times 9. Okay, let's find out what that is. 12 times 9. That's 108. 108. X. Okay. Well, in this case, if we try to compare these two, 108x with 96x, well, the numbers are not the same. So in this case, not a perfect square trinomial. All right. So not a perfect square trinomial. In some cases they are. In some other cases they are not. All right, let's look at the next page. What do we have for the next page? Well, so we have factor differences of squares. Okay, so the factorization of a difference of squares is the product of disconjugate binomials, as we saw earlier in this chapter. So earlier in this chapter we did this. Foil these guys to obtain this difference of squares. And by the way, it's worth noting that when we have a squared plus b squared, that's a prime quantity, and therefore we cannot factor. So let's look at some examples. How do we go about factoring differences of squares? Well, I would like to rewrite this as some quantity squared minus another quantity squared. Okay, so what quantity squared is x squared? Well, in this case, x. What quantity squared is 9? Well, that's a 3. And then now that we have essentially a and b, well, all we do is simply use the formula a minus b, a plus b. That is a minus b, or x minus 3 times x plus 3. And we're done. That's all we have to do. Let's do another example. What quantity squared equals 16y squared? Well, in this case, that's a 4y, because 4 squared is 16, y squared is y squared. Minus the quantity whose squared is 25, that's a 5, because 5 squared is 25. So, when simplifying this guy right here, well, let me actually put this so we don't get confused. That's going to be simply 4y, 5, 4y, 5. In one case, a plus and then a minus, or a minus and then a plus, doesn't matter. And we're done factoring these differences of squares. Let's look at another example. Well, 50 minus 8x squared. Well, number one, the number 50 is not a perfect square, and same with the number 8 is not a perfect square. So the first thing we might want to do is factor a GCF. In this case, notice these two numbers 50 and 8 are both even numbers. I'm going to divide by 2. I'm going to factor out rather the 2. And when I do that, well, I'm gonna be left with 25 and 4. And surprise, surprise, these two guys right here are perfect squares. So what am I going to do in this case? Well, let me put this bar right here. So this is the same as saying 2 times, put brackets, quantity whose square is 25 minus quantity whose squared is 4x squared. So in this case, 5 squared equals 25, and 2x quantity squared is going to be 4x squared, because the power 2 to the second is 4 and x to the second is x squared. So let's write this in the form of a difference of squares. Well, in this case, don't forget this 2. 1 plus, 1 minus, or 1 minus and then 1 plus, 5 plus 2x, 5 minus 2x. Final answer. We're done. Let's do one more. P to the 4 minus 16. Well, in this case, even though we're factoring a difference of squares, well, this is a difference of fourth, but we are going to initially treat it as a difference of squares. So how is that going to do that? Well, number one, I'm going to do, let me put it below, that's, let's say, p to the 4, that's, well, what quantity squared equals p to the 4? What quantity squared equals 16? Well, in this case 4, and in this case p squared, because p squared, when we have the power of another power, what we do is to multiply the powers, and 2 times 2 equals to 4. And in this case, well, we need to write this as 1 plus and 1 minus. Okay. Well, in this case, p squared minus 4 plus 4 and p squared minus 4. All right. Now, essentially, we're done, if you will. However, if you put this on your homework as a final answer, it's not going to mark you correct. It's going to tell you something like, well, although your final answer is correct, it's not fully simplified or something like that. And the reason for that is because if you look at the second factor, p squared is another difference of squares, so we need to keep going. All right, so this is p squared plus 4, which is prime. This one cannot be factored any further. This one we just leave it, p squared plus 4, and then that times p plus 2, p minus 2, which is the factor form of this guy. And we are done factoring differences of squares. Alright, now let's do the last part of this section, which is factor sums and differences of cubes. Well, what are we going to do in this case? We need to essentially know how to use these two formulas, difference of cubes. Notice the power R3, that's how we know these are cubes. In this case, difference of cubes because of the minus sign, and sums of cubes because of the plus sign. And if you look at these two formulas to factor these differences and sums and differences of cubes, they look the same. AB, a squared, AB, b squared, AB, a squared, AB, b squared. Well, if you would like to memorize, try not to memorize the formulas, because otherwise you might there might be some room for a silly mistake with some of the sign. Instead, let me give you this mnemonic to memorize the sign pattern. What do we mean by SOAP in this case? So SOAP, this means same, opposite, and always positive. So what do we mean by this? Well, if we have a minus, what's the next sign? Isn't that the same? And then the opposite. And then the last on both, it's always positive, or whatever difference or sum of cubes, the last term is always positive. Now let's verify the slope for the sum of cubes. So we start with the sum. The next is the same sign, the opposite, and again check that it is always positive. Now, how are we going to factor this sum of cubes? Well, number one, what I'm going to do is I'm going to write this as something cubed plus something cubed. In other words, what quantity cubed is going to give me x cubed? Well, in this case, x. Maybe I should have used a different color here to make a distinction in the previous step. Well, what quantity cubed is going to give me 8? Well, 2 to the third power is 8. So in this case, we have something of the form a cubed plus b cubed. So we need to factor using the formula, okay? So a essentially is x and b is 2. All right? So a minus b. What's a minus b? Well, that's going to be 2x minus 2. Well, actually plus 2 because it's a sum. X plus 2 times a squared, that is the quantity a squared x squared, and then minus the product of a and b, which is x and 2, that's 2x, and the squared of the second term or the b squared, which is 2 squared, that is 4. Final answer. That's how we factor sum of cubes. By the way, this is it. I know what you might be thinking. Well, we still have a trinomial that we might want to factor using the double bubble method. However, it is a fact that this second degree polynomial that we obtain out of the factoring of a sum or difference of cubes, it's always primed. You cannot factor over real numbers. So, in fact, try it. Factors of 4 that add up to -2. Well, factors of 4, it's only 2 and 2. Well, 2 times 2, 2 plus 2, that's 4. 2 and 1 times 4, well, that's going to be 1 times 4 is 4. 1 plus 4, that's going to be 5. We won't ever be able to get this -2. All right, let's do the next one. Now we have a difference of cubes. Quantity cubed minus quantity cubed. Well, let's see. Let me actually make this a little bit more interesting. Well, in your PDF file, you will find it updated. And in this case, I'm going to change this to 64. All right, I'm going to turn that into a 64 to make it more interesting. All right, so let's see. 64p cubed. So what quantity cubed would give us 64p cubed? Well, in this case, 4p, because 4 cubed equals 64. P cubed is p cubed. Minus what quantity cubed would give us 27q cubed? So I would say 3q. Because 3 to the third is 27 and q to the third is q cubed. Alright, so now we're going to use the, let's say the difference of cubes. So in this case, same, minus, and I'm going to leave some space for the rest. Actually, A in this case will be 4p and B will be 3q. So in this case, A minus B, which is going to be 4p minus 3q, 4p minus 3q, and then, well, we need to square the A term, which is 4p, but don't forget to actually, well, let me put brackets here, if you will, parentheses, 4p squared, and then plus the product of A and B, which in this case is 4p times 3q, and the quantity B squared, which in this case is 3q, squared. So I'm going to simplify that in a further step. In this case, in the previous example, well, we got a simpler question in this case. So we didn't need to do all these steps. So this is going to be 4p minus 3q times 4 squared, which is 16p squared, plus 4 times 3, which is 12p cubed, and 3 squared, which is 9, q squared, which is q squared. Okay, so hopefully my writing doesn't confuse you, because my 9 looks a little bit similar to my q, but I put this bar right here to make it look like a q. And this is pretty much final answer. Alright, let's do one more example. Let's see, let's write this as some quantities cubed minus some quantity cubed. In this case, well, what we got, y and 4. We already got these numbers earlier. Well, that's that's going to be pretty simple, I guess. So a equals to y and b equals to 4. So what is this going to be? Okay, let me go a little bit sideways here. So minus and plus and plus. All right. So y minus 4, and then the y quantity squared. So that's y squared. And then the product of a and b, or y and 4, which is 4y, and then the b quantity squared, which is 4 squared, or 16. Final answer. Alright, and this is the end of this section. I'll see you in the next video.